Hello, Mrs. Tole here. So today we are going to attempt some question on electricity. So we're going to do some question here. So one question on EMF. Now, three resistors are connected to a battery with an unknown EMF and unknown internal resistance R as shown below. Ignore the resistance of the connecting wires. So we have our switch there. In addition, in a definition of the EMF of a battery given below, A and B represents missing words or phrases. The EMF of a battery is the maximum. We know that maximum energy, okay? Then supplied by a battery per unit charge. So it's a unit charge or per kilo. So we can write F to indicate the A is energy and B is unit charge. Now with the switch S closed, the voltmeter reads 2,63. Calculate the equivalent external resistance of the circuit. So what we see here is a parallel connection. So when the switch is closed, so we are going to get our series here, part of the series connection here. The total there is 7. Okay, so here for 1 over R parallel, okay, it's going to be equals to 1 over 7 plus 1 over 7, which is going to be equals to 2 over 7. And in this case, RP will be equals to 7 over 2, which is going to be 3 over 3,5. So this is 3,5 ohms. Okay, done with that one. Now, switch S is now opened and the voltmeter reads 2,8 volts. Now, we can see that we have got what call two different values here. This one is the smaller value. Why? Because we are having parallel connection. Then here, when the switch is open, we are having a series connection. Okay, so when we have a parallel connection, we are more current is being current is flowing there, and when more current is flowing, we are losing more volts, and when you're losing more volts, we have a lesser reading. Okay, now opposite is true for the series connection. Now let's look at the question here that we are having. So they want us to calculate internal resistance of the battery and the EMF of the battery. Once we have these two, you must think of a simultaneous what you call equation. Okay, you're going to solve this using applying simultaneous equation. So because you are going to be using the equation E, which is EMF is equals to current in the bracket R plus R. So in this case, you are looking for two unknowns, which is your E, and what is it? And R. So we've got two unknowns there, which is an E and R that you need to look for. So let's look let's check when we've got an open circuit and we have a open switch and a closed switch. Let's see here. Let's see if we have a closed switch. Then let's use our equation here. On the open switch, when the switch is open, what are we having? We are having 2,8. But what we are missing here is current. So how are we going to calculate the current? Current, we know that is equal to V over R. And in this case, V is 2,8. And our R is equal to 7. And we just punch in our calculator and see what we get there. It's going to be 2,8 divided by 7, which is going to give us 0.4. So it's 0,4 amps. So in our equation, we're going to substitute the values that we have equals to 0,4 in bracket. R is 7 plus small letter r. So we've got two unknowns, R and EMF. So here EMF is equal to 0,4 times 7 is going to be 2,8 in this case, plus 0,4 R. Okay, let's go on to the second equation that we can have. It's going to be EMF. Let's also calculate the current first. Let's calculate the current first. It's going to be V over R. In this case, we've got 2,63 divided by 2,63 divided by 3,5 that we already calculated there. And when what do we get there? We're going to get 2,63 divided by 3,5. We get 0,75. 0,75. And for us to calculate for us to calculate the equation here. To have the equation, we're going to say I is equal to 0.75. We have our R there inside, which is 3.5. Sorry about that. 3.5 plus our small letter r. Now we can have our full equation there, which we're going to say this one here, 0.75 times 3.5, we get 2.63. 2.63 plus 0.75 r. Okay, then you equate the two. So when you equate the two, you're going to have 2.8 plus 0.4 r is equals to 2.63 plus 0.75 r. Then if you check 0.4 that side, it's going to be equal to, we're going to have 2, let's put this one here, 2.8 minus 2.63 is equals to 0.75 minus it's going to be minus 0.4 r and r there. Let's see what we have here. 2.8 minus 2.63, we get 0.17. So it's 0.17 is going to be equals to 0.75. 0.75 minus 0.4, we get 0.35. So it's going to be 0.35 r. And here we divide by 0.35, divide by 0.35 to get our r there. This one cancels there. Let's see, 0.17 divided by 0.35, we get 0.485. So 0.486, which is up 0.49. So it's going to be 0.49 ohms in this case. So if we are to substitute this value here in one of our equations here, it's going to be EMF is equals to 2.8 plus 0.4 in bracket there, 0.49. Okay, so in this case here, we're going to say what we have there is times 0.4 plus 2.8. We get our resistance, our EMF here as 3. Approximately, it's actually 3, which is EMF is equals to 2.99, which is actually 3 volts. Okay, so that's what we have here. That's how you calculate these type of questions. For next time, once you see internal resistance and EMF, you think of what you call simultaneous equation. Okay, until next time.